Archana Sharma from Noida Institute of Engineering and Technology, Pharmacy Institute, and I am here to deliver my lecture on the topic formulation of suspension. In the previous lecture, we study about the introduction of suspension, what is suspension, what are its classification, what is the particle behavior, difference between the deflocculated and the flocculated suspension. Now, in this lecture we will discuss about formulation of suspension. The formulation of suspension depends on whether the desired suspension is flocculated or deflocculated. Two approaches are commonly used. One approach involves the use of structured vehicle to keep the particles in a deflocculated state, or another approach is to keep the particles in a flocculated state in order to prevent cake formation. The third method is a combination of earlier approaches to prevent the settling. So, here in this diagram we see we take a solid particle, okay, and we add a wetting agent so that the particles get wet in the dispersion medium, and we add a dispersion medium. Now, we mix the solid particle in the dispersion medium so that uniform dispersion of suspension is formed. At this stage the suspension is in a deflocculated state. Now, at this stage if we are going to incorporate a structured vehicle into the system, we form the deflocculated suspension in a structured vehicle as a final product. If we add a flocculating agent at this stage, we form a flocculated suspension as final product, or if we add a flocculating agent as well as in structured vehicle both in the third approach, then we will form a flocculated suspension in a structured vehicle as the final product. First, we will discuss the structured vehicle in deflocculated suspension. Okay. So, what is structured vehicles? Structured vehicles, these are the vehicles which exhibit pseudoplastic or plastic type of rheological behavior. So, these are those substances which are having a non-Newtonian type of non-Newtonian characteristics. Okay. That is why they exhibit pseudoplastic and plastic rheological behavior. These also possess certain kind of thixotropic behavior, that is gel-sol-gel transformation to improve the physical stability of suspension. Okay. So, during a storage, a shear thinning system acquire a gel like structure so that the particles do not settle. So, on storage, during storage in the suspension, these when structured vehicles are incorporated into the system, they prevent the particles from settling, thereby the system is acting as in gel. On shaking, the viscosity decreases and the suspension becomes a solution, so that uniform dispersion of solid can be achieved. On shaking, the viscosity of the system, it get decreased. Okay. It decreases and the system shift from the gel state to the solution state, okay, and uniform distribution of solid particles take place within the system. Again, when left aside or when kept for the storage, the suspension again they form a gel like structure. So, the system undergoes gel-sol-gel transformation. Structured vehicles are generally prepared using hydrocolloids. So, structured vehicles are generally hydrocolloids, and the hydrocolloids they have the tendency to get swell in presence of water. So, these get hydrated well in water, swell to a great degree and produce high viscosity at a low concentration. So, the characteristics of the high structured vehicles are they get swell in the presence of water, and to the some extent they increase the viscosity of the system at a very minimum concentration. These also act as a protective colloids and stabilizes charge. So, they provide a protective layer over the solid particles, thereby they acting as in protective colloids and they also stabilize the charge of the particles. For example, methyl cellulose, sodium carboxy methyl cellulose, bentonite, hydroxypropyl methyl cellulose. Then next approach is controlled flocculation in flocculated suspension. What do you mean by controlled flocculation? Here we promote the formation of flocks, okay, but that formation of flocks is controlled up to the certain extent, okay. Hence, it is known as controlled flocculation in flocculated suspension. Once the powder are poorly wetted and properly wetted and dispersed in a medium, then flocculation can be produced gradually by addition of flocculating agent such as electrolyte, surfactant and polymers. Okay. So, what we do? We take any solid particles, okay, for which we have to make a suspension, we disperse in a liquid medium, and at this stage we add a flocculating agent which promotes the formation of flocks such as electrolytes, surfactants, polymers, etc. Different approaches are used to achieve flocculation. First is most dispersed particles possess a surface charge. The intensity of this charge can be reduced by addition of agent with an opposite charge. As a result, the zeta potential decreases and the particle establish attractive force between adjacent particles. So, first approach is that in this we add addition of the oppositively charged particle with that of the charge which a solid particle possess. So, if my solid particle possessing positive charge, then I will add some flocculating agent which is having a opposite charge, that is a negative charge. Okay. So, that the zeta potential will get decreases or neutralize, and the two particles they establish a attractive force between them. Surfactants and polymers are long chain compounds. These substances act by adsorbing a part of their change on particle surface and projecting out the remaining part into the medium. Another approach is by adding a surfactant and polymers, since these are long chain compound and they form a bridge between the two particles, okay. Thereby they are going to stabilize the system. So, first approach is effect of electrolyte. We will discuss the effect of electrolyte by considering an example. Suppose we are preparing a suspension by taking bismuth subnitrate. Okay. So, what will happen when bismuth subnitrate suspension is made in water? The bismuth particles assume a large positive charge or zeta potential. So, what we do? We take a bismuth subnitrate, we disperse into the water. Since we know that bismuth particles, they are having a positive charge on their surface. So, the zeta potential of the system is also positive. Okay. So, if we look into this diagram, okay, this potential energy diagram, so in the initial stage, okay, in the initial stage, if we are preparing a suspension, for example, by taking bismuth subnitrate, so what will happen when bismuth subnitrate particle is dispersed in water? So, it is considered that all the particles of the bismuth, they possess a positive charge on their surface. Okay. Take the like charge on the surface experiences repulsive force and the system becomes deflocculated. These particles resist collision even if they are brought together by agitation. Okay. So, at this stage, since all the particles of the bismuth, they are possessing a positive charge. So, at this stage, the two particles, they experience a repulsive force between each other. Okay. And at this stage, if we are going to measure the potential, we will get a high potential for repulsive force. Okay. High zeta potential of repulsive force, and since here the particle is acting as an individual particle, the system is in a deflocculated state. That is, the system is having a formation tendency to form a hard cake, and hence the system is in a caking zone. Okay? Clear? This peak shows the caking. So, to overcome this, to prevent this problem of formation of hard cake, what we will do? We will going to add a flocculating agent of a positively charged. So, when a flocculating agent monobasic potassium phosphate is added to the above suspension in a small quantity, the negatively charged phosphate ion get absorbed on the positive charge as bismuth particle. The force of repulsion decreases and the attractive force begin to operate. As a result, the positive zeta potential decreases and the solid begins to form flocks. So, what happened? At this stage, if we are going to add a negative charge, negative charge flocculating agent, what will happen? Now, with each positive charge, negative charge is associated. So, at this stage, this force of repulsion P, it gets decline slowly. Okay? And the repulsive force between the particles, it also get decreases, okay, on with the subsequent addition of the negative charge. Clear? And the zeta potential, the zeta potential is also start declining. Clear? At this stage, the system with the addition of the flocculating agent, what will happen here? Now, there is a formation of flocks take place. Okay. The particles, they start forming the flocks. Now, the system shifted from deflocculated to flocculated state. Okay. So, this will also increase. Now, the system is in this non-caking zone or in a flocculated state. This is your flocculated state. Okay. In the flocculated state, what will happen? Flock formation promoted and there is no formation of hard cake. Clear? On further addition of electrolyte, the zeta potential decreases gradually and becomes 0. During this stage, suspended particles remains as flock. On further addition, electrolyte disperse on further addition of electrolyte, dispersed particles assumes a negative charge on account of excess adsorption of phosphate ion. As a result, the zeta potential becomes sufficiently negative. Once again, particles experience repulsive force. Thus, the suspension changes to a deflocculated state, and this is evident from its low volume of sedimentation. The only difference from the initial state is that now the system has a negative zeta potential. So, if we look back on further addition of the electrolyte, what will happen? The zeta potential, it gradually decreases and becomes 0. Okay? At this stage, the particles are in a flocks state. Okay? But if we further add electrolyte, what will happen? Now, the zeta potential will again, what happen? Will again at this stage, it will on further addition of electrolyte, dispersed particles assumes a negative charge. Okay. And so, on further addition of the electrolyte, what will happen? Now, the zeta potential will become negatively charged, and here once again the attractive force decreases and the repulsive force dominates, okay, because of the access of the negative charge ion, and the system again enters into the deflocculated state, and again the system is in a caking zone. Clear? Okay. So, for making the system stable, we need to control the rate of flocculation, so that the system will remain flocculated and in the non-caking zone only. Another process is addition of surfactant. Surfactant improve dispersion by reducing surface tension. They act as wetting and deflocculating agent. In case of ionic surfactant, the head portion adsorb on solid surface and tail projects outwards and form bridge between the particles. Such an arrangement brings about flocculation and prevents precipitation of solid. Okay. So, in surfactant we all know that there is a two part, this is your head part and this is your tail part. So, what will happen? The head part is associated with the solid particles and the tail part is associated with the solvent, thereby they form a bridge, chemical bridge between the two particles, and hence the system, hence they promote the formation of flocks. For example, sodium lauryl sulphate and sodium dioctyl sulfosuccinate. Another approach is polymer. These act as flocculating agent because a part of the polymer chain get absorbed on the particle surface, with the remaining portion projecting out into the dispersion medium. Hydrophilic polymer act as a protective colloid. They form a mechanical barrier or sheet around the particles and induce flocculation. Okay. So, another approach is polymer molecule. So, with the polymer, these are having the structure like this. Okay. So, what will happen when we incorporate the polymer into the suspension? So, what will happen? They get associated with the solid particle like this. Okay. Thereby promoting the flocks formation. Okay. For examples are xanthan gum has increased sedimentation volume of sulfaguanide suspension, presumably through a bridging phenomena. Then last approach is flocculation in structured vehicle. The principle of flocculation and structured vehicle are combined to get an improved suspension. The flocculating agent facilitate the formation of aggregates of uniform size, while the structured vehicles prevent the aggregates from settling. So, in the last approach we are going to use the combination of the above two approaches, that is the incorporation of the flocculating agent as well as the use of structured vehicle. Okay. So, if we discuss this approach by through this diagram, we will take a solid particles, okay, of any charge, whether it is a positive charge, negative charge or a neutral. Then we add a dispersion medium or a solvent. Then in that, first of all, what we do? We add a flocculating agent of opposite charge. Okay. So, what will happen? Suppose if I take a positive charge, then around this positive charge, negative charge will associate, okay, and this promotes the formation of flocks. And if I have taken a negatively charged solid particle, then around that positive charge flocculating agent is taken. Which promote the formation of flocks. Now, these flocks do not get settled. For what? To prevent the settling, we are going to add a structured vehicles. Structured vehicle at this stage. Okay. So, what will happen on adding the structured vehicle? The overall viscosity of the system will increase, and which restrict the movement of the particle or which prevent the settling of the particles, and they also impart a thixotropic behavior on the system, that is they promote the gel transformation. Okay. And hence with these two, by applying these two approach, we prepare a more stable suspension. Okay. Thank you.